All right, guys, this is part 2 of E1 and E2 review. Let me share my screen. Okay, so E2 is all about the factor theorem. So I'm going to just tell you as if you didn't already look at the notes or any of that stuff. It's probably better if I do a video for you anyway. So the factor theorem itself says that if a polynomial in the form x minus c is a factor of a polynomial f of x, then if you put the c value into the equation, then you should get 0, right? It has to be 0. So just remember that if you get something like, let's say x minus 4, then your c value is going to be equal to positive 4. If you have x plus 4, then your c value is going to be negative 4. Okay, because it has to be x minus something. And you can put x plus 4 in the form x minus something by writing it as x minus negative 4, which is why the c value would be negative 4 if you had a binomial that they're referring to in the problem. Okay, so the question is x minus 2 a factor of this function f of x? Well, there's something we can do here, and that is first identify your c. Your c value is going to be 2. So then you're just going to find f of 2, which just means put 2 everywhere you see x. Now, because when we put this in our calculator and we get 0, then according to the factor theorem that says that a polynomial with the binomial, we're talking about this binomial here, right? It has to be a factor of the polynomial if when you put it into the original, the f of x function, you get a 0 out. So we can say yes. And the reason is because f of c, which is the same thing in this case of 2, f of 2 is equal to 0. So when you put 2 in, you get 0 out. Okay. So that's the factor theorem. Then there's the remainder theorem. And the remainder theorem says that when a polynomial is divided by a linear polynomial, again, like x minus c, then the remainder of that division is going to be equivalent to whatever f of c is. All right, so for example, let's do synthetic division. We're going to divide f of x, which is x cubed plus 3x squared minus 13x plus 6. And we're going to use synthetic division. This is the same problem from the last example, but so I'm going to use synthetic division this time. So take the coefficients here in synthetic division, 1, positive 3, negative 13, and a positive 6. So we're going to see what happens when we divide it. First thing you're going to do is bring the 1 down, multiply by the 1 times 2 to get 2. And you're going to add 3 and 2 together to get 5. And you're going to multiply the 5 by this 2 and put the result here. So 5 times 2 is 10. Then we're going to add these 2, so we'll get negative 3. And now again, we're going to multiply it by this 2. So negative 3 times positive 2 is negative 6. And negative 6 minus 6 is just 0. So we do get a 0 remainder. Now, we said that here's your remainder, right? The remainder of that division is going to be equal to f of whatever c was, like we did in the last example. So if we do f of c, and our c value is equal to positive 2, if we do f of 2, just like from the last example, we know that f of 2 is equal to 2 cubed plus 3 times 2 minus 13 times 2 plus 6. And guess what that's equal to? It does equal 0. Okay, so the remainder, the red arrow, remainder of the division is equivalent to whatever f of c is, and it certainly is, right? Okay, so the factor theorem and the remainder theorem help you answer a couple of questions. Let me give you some examples. So is x plus 1 a factor of this function? Well, we know that what we can do is if f of c equals 0, then yes. So let's see, our c value is -1. So we're going to put f of -1 into this function. -1 cubed minus 2 times -1 squared minus -1 plus 2. And if you put that in your calculator, then you would find that yes, it is equal to 0. So yes, x plus 1 is a factor of, let's make this equal to f of x. Okay, so if when you put the c value in and it becomes 0, then yeah, you know it's a factor. You also happen to know that it's a 0. So this question here says, is -1 a 0 or solution? Well, think about it. If you factored something, you would factor it, right? Like however, right? And then you would set each factor equal to 0 and solve for x to find your solution. So we can say yes. Since we know that x plus 1 is a factor, then x is equal to 1, x is equal to -1 is a 0. It's another way of saying solution. Okay, so that's two different questions, right? You can ask, is a binomial a factor? And then you can use that, the factor theorem, right? Just by putting in your c value. If it's 0, then yes, it's a factor. And then it's a 0 also. If you know that a binomial is a factor, then all you have to do is set it equal to 0 to determine a 0 or a solution. All right, so another example here. Is x plus 1, should have said f of x here. Is x plus 1 a factor of that function f of x? So our c value is going to be, was this the same problem? Hang on a second. No, I think it's different. Yeah. So our c value is going to be -1. So we're just going to we're going to find f of c. So f of -1, now we're just going to put -1 everywhere we see x. So you have -1 cubed minus 5 times -1 squared plus 3 times -1. When you calculate this, you do not get 0, you get -10. Okay, so we can say no, since f of c, and in this case, c is -1, is not equal to 0. Now, then it asks, is -1 a solution of that same equation from above? Well, you can say no right off the bat, since we know x plus 1 from above is not a factor of f of x. All right, and a couple other kind of things I can ask you. So here's an example, and you happen to know that one of the zeros is -1. Another thing you know, if a 0 is -1, then you know that x plus 1 is a factor. Remember, on the homework assignment, I might tell you a 0, or I might tell you the factor, right? So you have to make sure you can go back and forth. Okay, so let's see. So if you know one of the zeros is -1, we're going to factor this. So in this example, they're just asking you to factor it. Okay, be careful on the directions. Sometimes they're asking you to factor, and sometimes they're asking you for the solutions. This is an easier problem because they just want you to factor it. So you take that 0 they gave us and you do some synthetic division with it. And what this will do is it's going to give us what we call a depressed equation. I'm just taking the coefficients from that function up there. Then I'm going to do some synthetic division. So 1 times -1 is -1, -2 plus -1 is -3, -3 times -1 is +3, +3 and -1 is +2, and then 2 times -1 is -2. And because they told us that -1 was a 0, it does not surprise us that we're going to get a remainder of 0. But what it does give us is it gives us what we call the depressed equation. So we know that x plus 1, because they gave it to us, is one of the factors. Now what we know is, since this is x cubed, we're going to take this one down to x squared. This will be x to the first, and this will be just 2. So the depressed equation is x squared minus 3x plus 2. But notice that what they're saying is they want you to factor it. So in order to fully factor it, all things must be factored, and that trinomial can be factored further. So we'll bring down the x plus 1, and then we can factor this by using the diamond method. So 2 goes on the top, -3 goes on the bottom. We're looking for factors of 2 that add up to -3. It's definitely 1 and 2, and they both have to be negative in order to add up to a -3. So we know that the other factors now are x minus 1 and x minus 2. So what you've done is you've fully factored this by using the 0 that they gave you here to first do synthetic division. Then you get the depressed equation and factor that further to fully factor it. All right, let's see, there's one other. Okay, so let's say, I'm going to do another little sub. I thought I typed this up, but I guess I didn't. Let's see, this is an example. Just this example. So I could also ask you to now find the other zeros or solutions. So how you would do that is you would set x minus 1 from up here equal to 0, and also x minus 2 equal to 0. So you add 1 to both sides here and you get x is equal to 1. Add 2 on both sides here and you get x is equal to +2. So I could ask you to fully factor. Where's my mouse? I could ask you to just factor. Wait, where's my mouse? Or I could just say, here's one of the zeros, find the other zeros. But either way, you're going to do what I'm telling you to do in this example. All right, guys. That is the end of part 2, and I hope you're watching these videos because I am spending time making them for you.